Hello, everybody. Today is January 6th, 2023, and we'll be discussing how we want to process operator CRs in OLM v1. With that, I'll hand it off to Daniel.
Yeah, thanks, Alex. So we're beginning a lot of our major developments on the operator controller. And before we get too far into that, we need to start making some decisions as far as how the operator controller does its reconciliation. Like if we're going to be doing that sequentially or in parallel. There are certainly benefits and downsides to both. But for the purposes of this meeting, rather than actually trying to decide on either of those, what I wanted to have us talk about here was basically talk more about the function of the operator controller itself and why this question is important, and like what the impacts are of choosing one or the other, and also the reasoning for why. Like I think with a traditional operator, we would be just doing, kind of sequentially reconciling our CRs through a queue, but also just the question of why we would not do that is kind of important to address as well. Um, so this is a just very free form discussion, and yeah, that's kind of the intro. Um, so I remember us talking about, just to kick things off with one topic at least. I remember us talking a little while ago about why, or one reason why we might choose to go with like parallel processing, and that was because we have some operators that have like cyclic dependencies. Um, that also this also could turn into a bit of a rabbit hole as far as like whether or not we're going to allow that. Um, so yeah, I don't know. I just wanted to kind of introduce that, and if anybody has some follow up to that, yeah, go for it.
So I personally don't think we should allow cyclic dependencies. It doesn't
Mhm.
sound like a good recipe. Like the thing that I think about the most when thinking about this issue of single versus multiple, is that the more information you have, the better the solution you can provide, right?
Mhm.
So to articulate an example, so let's say if we're doing it serially, then we're saying, okay, look at this. This is the thing I want to install. Look at the current state of the system. Can it go in there? Yes. Okay, cool. Put it in there. And then you go to the next one. And, keep doing the same thing. But you might reach, a step down the line that says, oh, no, I conflict with, the thing that you installed 2 things ago now. Whereas if you just piped everything, then it might have worked out the constellation of bundles, which could give you the consistency that you're looking for. Now, the question is, how often does that happen? Does it really matter? Because even if I'm grouping, like at some point, the system is discretely running the resolver, right? I could group a whole bunch together, but then I could just add a single one afterwards, and then that's kind of like the same as doing the sequential mode in terms of being able to find a solution that works. So
aren't there cases where the sequential mode will essentially fail in that, like, if I'm only ever looking at, well, so first let me verify an assumption. In the sequential mode, we're saying, look at this one operator CR and compare it with what we currently have installed. Is that right?
yeah, that's
Like,
how I do it. Yeah, like
yeah.
Look at the system and then say, can we add this thing to it?
Yeah, so I think the problem that we would run into there, and I don't, again, like, I don't know how often this would be, but it seems like it would be often enough that it's almost a non-starter, is that you could easily have a setup where today you've got, let me think of a reasonable example. Really, think about like 3 different operators in question, right? So yeah, A, B, and C. If you've got if you have A installed version 1, and then you say like and A depends on C, so now you've got C version 1. And then you say like, okay, now I want to install B, and B says I conflict with version 1 of C. Then the resolver is going to come back and say, sorry, you can't install B at all. But what we could do is, if we knew about everything else, we could say like, oh, well, actually there's a C2 available in the catalog. A and B both work with C2. So really what you need to, like, the resolver answer should be, okay, I'm looking at A's constraints and I'm looking at B's constraints and I'm looking at C, and I can see that like, okay, there is a solution to this, but actually have to do an upgrade of C and an install of B to make everything still consistent. Whereas if we do things sequentially, like, you'll never be able to install B until you somehow figure out yourself that you need to go and upgrade C.
Yeah, I think Joe, I agree with you. You have to look at this holistically. I don't think we can look at one operator at a time. We really need to look at it holistically.
A quick question on Joe's example. Joe, you had mentioned that in your example, you install operator A and B. A has a dependency on operator C, and because we resolve operator A first, we then install B1 for operator C and B1 for operator A. But then when we try and process operator B, there's a requirement on B2 of operator C, or it, and then so I think what we'd see, and you can correct me if I'm wrong, as long as there's a valid upgrade path from operator C V1 to V2, the resolver would upgrade everything, provided that operator A didn't have a hard version requirement on operator C V1. It would just be in the second resolution where that would take effect, right?
I don't think so, because B, like, it seems like what, and again, tell me if I'm wrong here, but it seems like what we would say is like all of the installed operators are mandatory. And so we have to have C1 still installed when we also want to install B, which requires at least C2.
Yeah,
I don't know that that's not how it works today, right? With
No, but today we do a global resolution within the context of a namespace.
Right. It's
Right.
the same thing, except think cluster instead of namespace. And it is the same problem.
right, but that happens. Sorry. So if we're assuming, so if we treat the resolution of the namespace as we do on a cluster level right now, or reverse that, if we treat the cluster level resolution with the operator CRs, as we would do today with subscriptions that are namespace, the first resolution, A requires some GBK from C, and as long as it's not hard coded to us, like as long as it just requires like the GBK on operator C, when operator B is processed, you would go to B2 in your example. We would facilitate that upgrade.
I guess my question is, why do we care about what is currently installed when we're doing a resolution? Like, what's currently installed has literally zero bearing other than upgrade paths on what the possible next resolution output is.
Well, that's
I could easily say like, oh, I'm like, one of my transitive dependencies is no longer required at all. I think there's just cases, like there's all these cases related to transitive dependencies that break if we don't consider the universe of all requested operators.
right, but I think you would still consider, like, if I'm processing operator CRB at, after, A and C were installed, we would consider A and C at that point, right?
But what are you considering? Like, what do you know about A and C for that resolution? Do you know do you know what operator A says it wants for A? Like if, oh, well, here's another example, maybe. Say I've got operator A, mandatory, it has, like, I've declared on my cluster, I need operator A version 1. And then later, I want to install operator. Well, let me think about this. I don't know. I'm having trouble conceiving of an example. I feel like there's cases where, like, depending on version range, dependencies and conflicts, there's no way to progress correctly or efficiently if you're not considering the full universe.
Well, that's my point. So let me rephrase something. When I think of like processing these in serial or parallel, I've always thought of this as like, we're either like, anytime a new operator CR is created, we think about all the operator CRs that exist and then install it, versus doing it in a parallel style where we just wait like a couple of minutes and then process the operator CRs and then consider the universe then. Because I agree with you, like if you do it like as the events come in, you get this issue where the resolver is rapidly going to create a solution for when the second you create operator A, and then when you create operator B, it's going to consider that solution immediately afterwards. So you get a bunch of like spiky events rather than doing thing on a timed basis where
I don't think that's the problem. Like, I think, in fact, like I think we should do it event based, such that like if someone says I want operator A, and then they say they want operator B, operator controller should be eventually consistent. And some of this is going to have to come in with like the whole like operator condition API, right? Like, where depending on the timing of stuff, if we've gotten to the point, like if we do A and B really quickly successively, if A gets installed before we're processing B, then okay, now we've got to consider the fact that A is installed, and if B says it needs to have a different version of A, we may not be able to install that version of A because A is already installed, and now we need to honor its upgrade path. But if
This is kind of a more foundational question. Sorry to interrupt you, but
go ahead.
Like in that case, let's say you applied A and B basically simultaneously, and in that case, you are capable of processing both, and then realize that like maybe you can't install B. Like what do we do in that case? Do we install A anyway, and then just say like, hey, we can't install B, or do we install nothing?
I think we would, like, if you're saying if A actually gets installed, or if A does not yet get installed.
Well, I'm saying like assume we actually have all the information, and B cannot be installed if A is present. Just for instance, do we not install any operators? Do we not install A and B, or do we only install A or only B? Like, do we just fail the whole thing? I don't know.
I think in my mind, like every time we do a reconcile in the operator controller, we have a cache of what's in the cluster that tells us the current state of the world, at least in terms of what the reconciler is aware of. And part of that is going to be like a bundle deployment for A or not, and an operator condition for A that says it's ready to be upgraded or not. And so we just like always use that state to make decisions, and it's always deterministic. And so like if we're doing a resolution and we see that there's an operator object for A and B, and we see that A is installed, and we see that B wants a new version of A, and we also see that A's operator condition says it's not ready for upgrade, then we don't install B, and we say like, sorry, like can't do it. But then later, the operator condition for A changes and it says, oh, ready for upgrade now. So that triggers another event in our controller. And then we reconcile again. And now the state says A is ready for upgrade. And then we see that the resolution says that, okay, like now there's a path here that's valid. And so therefore now we can install B. So I think it's all like, I think it is all event-based, and we just have to make sure that the inputs to the resolution all have event-based triggers such that we always resolve anytime there's anything that changes about what the resolution input is.
Okay, so maybe this was just in this specific case, but what came to my mind when thinking about sequentially versus parallel was like a bunch of CRs like stacked like up in a queue, and you're just reading them one off at a time, versus you get some event like maybe a bunch of them were created all at once, and then you just pull everything off the queue and consider all the CRs at once. Is that not kind of not what we're talking about?
No, I
So
think
I think it depends on when when you start creating the CRs versus when you finish it, right? So if you created some script that applies a operator CR every 5 seconds, you can imagine that we reconcile the first one before the second one's even created, and then we immediately get another event for the second one. I think if we're doing an event-based system, you know, we'd have to hope that they're like, there's no guarantee that we're ever going to have all the CRs that they plan to apply before we start. We'll effectively take the snapshot of all of the operator CRs that we think exist on the cluster at this point. Which the more I think of, I think is fine, because we would just, you know, as those other ones get created, we would, you know, kick off the reconcile again and again and again.
Right. I mean, the thing is, what we need to, so events ought to trigger the reconciliation, but not necessarily force a reconciliation. And the reason and basically what I'm trying to say is, only if the operator CRs change should there be, you know, a reconciliation. So as an example, 3 operator CRs are created all of a sudden. We get the first event that's based upon the first one. We reconcile, and then while we're reconciling, the system has created the other 2 CRs, and you know, we still have 2 events. But by the time we get to the second event, all 3 CRs are there. The third event indicating the creation of the third CR doesn't really matter and shouldn't really necessarily trigger a reconciliation.
So I think what would happen in that case is, so the timing of all this is a little bit fuzzy usually, because we have a cache. And so like as events are happening, the API server is sending our informer the events, and we're populating them in a cache. And by the time we get to reconciliation, we're going to say like client.list all these operator CRs. And we're going to say client.list all the operator condition CRs, and we're going to say, tell me what my catalogs say. Like we're going to do all of this every single time we reconcile. And it's like this idempotent thing, right? It does not matter. Like we're going to get the full state of the world every single time we reconcile. And then it's idempotent such that like for any given set of full state of the world input, there's always essentially like a very specific and expected output, right? So like if we get to that third reconciliation and nothing has actually changed, but we have an event, then we'll go through and we'll see like, oh, nothing has changed, so therefore the output is the same, so therefore nothing to do. But it's not that we'll just cancel reconciliation. We'll process the event and look at the state of the input and do all of the stuff that, you know, you would reconcile, and then at the very end of it, we'd say like, oh, yep, nothing changed here, we're all good.
Yeah, and you know, if you there's another recording that you can reference where we discuss like making observability part of the resolver. We discussed like using events and IDs to basically feed stuff through the resolver. You know, if we somehow made it so the set of inputs influence the event ID, or if we had some other tracking mechanism, you could skip the heavy lifting of running through the resolver if the, we'll call it the input hash hasn't changed going into it.
In my mind, if we try to do anything like that, we're gonna build bugs. Like in
That's
my
fair.
mind, we should run through all of the logic and hit the caches every single time and ask, you know, make sure that we're looking at all the entities every single time, and we're gonna do a resolution every single time. And if essentially, like if the resolution at the end gives us the exact same list of bundle deployments that we already have, then nothing has changed. And so there's nothing to do. But I would expect us to, I think I would expect us to call the resolver every single time there's a resolution.
I'm fine with that. I just think there's an opportunity for optimization at some point where, you know, we've said that we want to make it so that the resolver is deterministic based on the set of inputs that it's given. And if we're trying to achieve that goal, comparing the inputs to the inputs versus the outputs to the current state of the world is effectively the same thing. But I agree with you, there's less opportunity for us to have written and introduced a bug if we go with that second route of comparing the outputs to the to the existing state of the world, right?
Yeah, and I think the thing to think about is like, what are you using as a proxy for what you think the resolver output is going to be? Like if you say like, oh, I put something in the status and now I'm relying on the status of something to tell me that the resolver is going to tell me the same thing. Well, you don't know that for sure, because maybe this time we redeployed OLM and now the resolver version is new and the inputs are actually identical, but we fixed a bug in the resolver, and so now the output is actually different because we fixed the bug. So
Yeah, but that becomes slightly less of a problem if we're doing pairs suggested approach of having immutable pipelines that get defined, right?
maybe.
But yeah,
Right.
and again, I don't think we need to dive into this any more than we did. You know, this is just like a premature optimization that I'm pointing out.
And I'm just going to mention that, you know, this is not something that should happen very often. It's not like we are doing data passing. We, you know, my opinion, performance is fairly low on the totem pole of quality metrics. So I mean, we can probably survive doing an extra reconcile. It won't affect the system that much, even if the results are the same as what we already have, because we won't be doing it that often.
Yeah, and if we do this well, then we're not really actually like, I imagine that most of this stuff is going to be based on information that we've cached in memory locally. So all of the collection of input is going to be happening async from reconciliation. And at reconciliation time, we're just going to be reading from our cache. So I like that, or at least that's how we probably should design it as much as possible. So yeah, I think unless we've got just like massive numbers of constraints and variables and properties, like resolution should be fairly cheap.
Certainly in the grand scheme of a large cluster. Downloading, installing the operators ought to be the more expensive operation.
Yeah, and not only that, but like, okay, say resolution is not cheap. Say it takes 5 seconds for a single resolution to run. Okay, well, that just means that in that 5 seconds, we've now seen a bunch of other events come in to our controller such that the next time we reconcile, we'll have a lot more state information and we won't have to have as many reconciliations because we'll get to the point of, well, maybe that's not true because we're still going to have all the events in the queue.
Yeah, I think the more we talk about this, the more I'm leaning towards the idea that we always process operator CR events as they come through, or, you know, like a change defi source. Any of those events can trigger the reconcile, right? And even if we went to a parallel approach where we process stuff like once in a while, once we thought we had everything, you can still run into a situation where as soon as you kick it off, you have a new event. So you just make it less likely, and you slow down like your response time to someone creating an operator CR.
But I mean, you don't need to process necessarily intermediate events. If those events, update the cache, you don't need, if 4 events come in, you just really care, and all the events update the cache, all you really care about is, okay, we got more additional events, just do the reconciliation based upon the most recent event we have that updated the cache.
Yeah, that's a good point, Todd, which is that like in a lot of cases when with these controllers, each event is processed separately. But because we're basically saying that the operator controller is it's kind of this global reconciler, and all of the events always end up doing the exact same thing, then maybe there's a way we can optimize by, dropping everything that's in the queue, and just like anytime there's anything in the queue, condense it down to exactly one event and process it once, and then go that way. But I don't know how simple that would be with controller runtime. We'd have to see.
Yeah, it'd be interesting to like convert, it's basically set a watch on operator CRs and convert them to like some array of operators that we add to the queue, and then like duplicate entries of that aggregate operator list are ignored.
Yeah, there's actually a way that now that I think about this, you could just trick, you could have a mapper, like in the controller when you set up a watch, you could have a mapper that just like maps every single incoming event to the same sentinel value request. And if you do that, then the queue automatically dedupes events from the same request.
Yeah.
So then you get
Yeah, that would be cool.
So I think we could do that.
So we'd effectively, instead of that, I mean, that would immediately remove the risk of, like you started reconciling it, 4 events came in before you were even able to reconcile the next event. And so like those 4 events came in, but from the, viewpoint of our controller, we have a single reconcile event with the current state of the world at the end of all those events flowing in.
Yeah, there is a flip side to this though, which is that there very well may be use cases where it would be nice to know what operator changed. And I know this is like a very slippery slope, and I don't like this, but the reason I'm bringing it up is because we have this other problem that we're trying to solve around, the observability and debuggability of the resolver. And so if we're doing a global resolution and the resolver says unsat, then where do we put that unsat error? If we're doing things globally, the naive obvious answer is to put it on every single operator object that exists on the cluster that is related to this resolution. That doesn't really help that much, because like what probably actually happened is there are a whole bunch of operators that are just fine. They all work. And then as soon as we add this other one or these other 2 or whatever, then things become unsat. And so it'd be really nice if you could say to a user, here's the minimal change you can make that'll get things back to your current set of stuff. And so maybe you start thinking about the installed operators that way too. Like you could think about it like, okay, well, I've got 87 installed operators already running. So theoretically, there was already a resolution that meant that those 87 could work together. So eliminate those operators from the list of things I'm going to update and only start looking at this other set. Although that probably won't work either, because like we were talking about at the beginning, like it could be that you add a new operator and it's actually one of the old ones that causes the conflict somehow. So I think that's a very difficult problem.
It's also interesting because if we went down this approach of like mapping them to an aggregate list of operators, in the scenario where I create 4 operator CRs in a row, I would get a different aggregate each time. I would have a length of 1, length of 2, length of 3, length of 4. As opposed to if you do it just as an operator events based system, there's an opportunity for your snapshot to include all 4 on the first reconcile.
I don't think that.
I hate to interrupt this discussion. I think it's really valuable, but what it's sort of sounding like to me, and I'm just doing this because we're a little bit over time, is that we've actually achieved parity on the base discussion of this meeting, and we're now kind of getting into like important details on how to implement that. Am I correct in that assessment of how things are going? It could, because it sounds like we're kind of all in agreement that there's really no good way for us to do these installs unless we have like unless we fully understood the state of the world, and kind of do this event based, kind of gather all the information and then act on it, and optimizations aside, that's kind of foundationally what we'll be doing. So is that correct?
Yeah, I believe we've agreed that it needs to be holistic, take the whole state of the system into account. So effectively parallel, I guess you could say.
Yeah.
Yeah, just yeah, but event driven being the key.
Yeah.
Okay.
Yeah.
And then just for my own betterment, just to make sure I have my head wrapped around this correctly, in the scenario that I create, like let's say there's 2 operator CRs that I'm going to create. Operator, like the resolver is going to fail if I have operators A and operators B as constraints sent in. Okay. And so just so I can visualize this manually, operator A comes in, it's the only thing that we see in the state of the world right now, we install it. Immediately after we start installing, we find out that the resolver is going to fail if we have operators A and B, but the install for operator A that was started is going to continue, and then it is up to the user to fix the B install. Is that correct?
I think it all depends on what the current state of the world is when you're looking at the next resolution for B, right? Like,
yeah, exactly.
A is going to be in some intermediate state that you know what the intermediate state is. So either you're going to decide, oh, I can use this other A version, or you're going to decide like A is installed, so therefore I need to feed that into the resolver as another sort of constraint, and you'll get the answer back from the resolver one way or the other.
Okay.
I think there's probably a potential here for conflict errors, right? Like maybe you don't know for sure that you shouldn't be doing something. But I would hope that would mean that we would try, like, let's say your cache isn't up to date, for example, right? Like if you're always looking at your cache and something has happened in the background since you last looked, and like when you're looking at the operator B resolution, your cache is not actually reflective of what the real state of the cluster is. Eventually, you're going to make a decision potentially that conflicts with what the real state of the cluster is. When that happens, we'll get a conflict error, and then that should just be like we return that as a reconcile error. When we return a reconcile error, that means we retrigger resolution immediately or with an exponential backoff. And then we try again. And the expectation is that eventually our cache will be up to date. And then eventually we'll be able to, arrive at a decision that is no longer a conflict for the cluster.
Okay. Okay, so event-driven eventual consistency, multiple retries with the back off, and okay. And then users can still pin operator versions with the operator CR. Okay.
Cool.
Yeah, so Daniel, to answer
Yeah,
your
go ahead.
question, it sounds like it's gonna be global state of the world. And I think then we don't have to do it here, but I think we then need to think about implications of that. And so that's what Kevin in the chat is talking a little bit about, I think. And then also the question I asked about how do we surface the right error messages in the right ways to the right objects that make this tractable. But I don't think, like, I think we just have to think about those problems as they are rather than try to work around them some way.
Yeah, those aren't problems that kind of throw this whole thing up in the air, right? They're just things that we deal with as a result of this architecture decision.
I think there are fundamental problems that we have to solve. Like, it could be that we say there's no way to break this down some other way such that it is easy to answer that question, but we also refuse to accept that we're going to update every single operator object with the constraint unsatisfiability error. And so maybe that means we have to have an architecture that has a separate resolution API that we put the resolution error on. So I don't think it matters for milestone 1 or even milestone 2. So we can go and build some stuff that kind of just disregards this whole problem altogether. But I think like it probably does have an impact, or at least has the potential to have impact on the overall architecture.
Okay, yeah.
But I guess maybe the last point I would make is that like we can do whatever we want right now. And even if we think it's not great, it actually is great if we do it. So that way we can see it and we can ask PM, we can go ask people, hey, is this ridiculous or not? And then we get some feedback and then we talk about it and make another decision.
Yeah, absolutely.
Yeah, and you know, just circling back to what Joe had said about like surfacing the error in the right spot. One of the big problems we had with OLMD0 is that if OLM started an install plan but failed to update some subscription, it just never fixed it. And so that's like one of those problems that we probably want to consider fixing, because we get into a state where we considered the subscriptions and everything. We ran the reconciler, we decided what needed to be installed, we started installing it, and then we found out that we didn't update the subscription, we lost everything. And then we just threw our hands and said, well, there's a subscription that says some package needs to be installed, but there's a CSV that isn't associated with it. So it now just fails and it doesn't upgrade. There's probably some way to improve this. You could do something like, before I install anything, I have to reference this event ID in a bunch of subscriptions, or you know, like the operator CR, or there needs to be some way to reference like the events and stuff that before we get into a state where we throw our hands up and say we're in a non-recoverable state because we cannot update a resource. So that's something we'll need to consider.
I will go on the record and say there's no such thing as an unrecoverable state in Kubernetes. That's just not a thing. Or at least it should not be in the new OLMV1.
Exactly. Yeah. Okay. With that said, does anyone have any last minute things they want to bring up before we conclude? All right. Well, thank you everybody for joining today.